Hello friends, welcome to our channel where we are presenting lessons in mathematics. Alright, so in this presentation we continue dealing with the questions from the 2019 past paper. Actually the paper is Mathematics General Proficiency of 2019 from the Caribbean Secondary Examination Council. All right, yeah, it's the Caribbean Secondary Education Certificate of the Caribbean Examinations Council of 2019. That is May, June. Okay, paper 2. The duration of 2 hours 40 minutes. So we continue picking some questions from here and try to handle it. But these questions are useful to any other person. Those that are doing the ECZ, this is what you need. These are part and parcel of your syllabus as well. Okay, so let's look at the first question. The equation of a straight line is given by x divided by 3 plus y divided by 7, and the answer is 1. Alright. Now we have been told that this line crosses the y-axis at point Q. Roman numeral 1. Can we then determine the coordinates of Q? Right. Look, if you have the Cartesian plane, suppose this is what we have. Suppose this is our Q. Alright? Because I've been told that this line passes through, cuts the y-axis, alright, at that point. It simply means at this point we need to have these coordinates, x, comma, y. You agree with me that at this point, well, this is the 0, this is x, and this is y. Simply means at that point, this is the origin, which is 0, comma 0. Meaning that the value of x here is a 0, alright? As long as it is passing through the y-axis, then the value of x is 0. So you can go straight and substitute so that you find the value of y. But for the sake of this question that is here, say what is the gradient of this line? It's better we first determine the equation, alright? It's better we put the equation in standard form. What is the standard form? We say y maybe is equal to mx plus c, where this is the gradient which they are looking for in the second part, and this is the y-intercept. So take note, this is the gradient, alright, and this is the y-intercept, right? The point at which the line is cutting the y-axis. So we need that, okay? So now, what are we going to do? There are a lot of methods of coming up with a standard form of the equation. So we want to make y the subject. So what we can do is, look, we have these denominators. We can get rid of the denominators. So what we can do here, we can say, we multiply throughout by 3. Right? So we're going to say 3 by what? X. Alright? Plus 3 by y is equal to 1 by what? 3. Okay. Again, you multiply throughout by 7. So you say by 7 by 7 by 7. This is over 3. This is over 7. Okay? So what that does is that this 3 and the 3 will cancel. You remain with the x by 7, you have 7x. Plus 7 and that 7 will cancel. 3 by y, you have 3y. Which is equal to 1 by 3 is 3, by 7 is 21. So this is the equation that we have. Alright, so now, we need to make y the subject. Alright, so we are going to say 3y is equal to, we can take this one on the other side, negative 7x plus 21. Alright? Our interest is to find y, so we can divide by 3, and divide by 3, and divide by 3. So what are we saying? Our y is equal to negative 7 over 3x plus 7. Okay? Now, this is what we have. Now, to answer this one, at the point where the line crosses the y-axis, so we are saying but x should be what? Should be 0. Meaning that y will be equal to negative 7 over 3. Here you put a 0 plus what? 7. So when you multiply a 0 by this fraction, it will be 0. 0 plus 7, it is 7. Alright? Meaning that the coordinates of Q are x, y. And what is our x? X is 0. Our y is what? 7. So these are the coordinates. Okay? Those are the coordinates. If you wanted here, we have said, okay, first maybe let's express this as a single fraction. It's one and the same. Where you say, okay, let me get the denominator here. Maybe get 21. Then you express it as a single fraction. It's okay. Okay, so number 2. Roman numeral 2. Take note, this is Roman numeral 2. Alright? Roman numeral 2. What is the gradient of this line? Here, you come back to this one. The coefficient of x here, after expressing it in standard form, is our gradient. So meaning that our gradient is equal to negative 7 over 3. So that is our gradient, which makes the job easy. Okay? So we can go to the second one. Okay, so let's look at the second one. The functions f and g are defined by f of x is equal to 9 over 2x plus 1. And g of x is equal to x minus 3. Roman numeral 1. So take note. We have f of x is equal to 9 divided by 2x plus 1. And g of x is equal to x minus 3. Okay. So now, we are saying take the value of x that cannot be in the domain of f. Alright? Now, you know, f can have a lot of values in the domain. But now we need to identify one value that should not be in the domain there. Alright? So now, what does it mean? Look. We know that the function f has been defined in terms of a fraction. Alright? And the variable is a denominator. It simply means that the denominator should never be equal to 0. Because if the denominator is 0, then the function cannot exist. Then the function does not exist. Then the function is undefined. So what we are trying to do here is, what value of x are we going to select so that the entire function does not exist? Alright? So, we are going to say, we know from our primary school that if you divide any number by 0, let's say 2 by 0, this is undefined. Alright? This is undefined. So what are we trying to do? We are trying to ensure that the denominator here becomes 0. Okay? So that the function is undefined. So, we are going to say, we equate the denominator to 0. So we are going to say 2x plus 1 is equal to what? 0. Right? So now we are going to say 2x is equal to 0 minus 1. And 2x is equal to negative 1. So we divide by 2, we divide by 2. Meaning that x is equal to what? Negative what? 2. So we are saying the value of which that cannot be in the domain is x is equal to half. X is equal to negative 1 over 2. not negative 2. So for x is equal to negative half, that should not be in the domain. Otherwise the function will not exist. Okay? That is how easy that question is. Okay? So we can go to the second one. Roman numeral 2 now. The first one is we get the composite function of f and g. We fuse these two. So we are fusing f onto g, g onto f. So we are going to say f g of x is equal to, so we are fusing this here. Take note. Alright? Because it is g that is going on to what? Into f. Okay? So we are fusing and getting this and put there. Okay? So what does this mean? So we're going to say f g of x is equal to 9 divided by 2 open bracket. Where there's x, we put that. So x minus 3 plus 1. This is 9 divided by, this by that is 2x. This by that is negative 6 plus 1. Alright, so f g of x is equal to 9 divided by 2x. What is negative 6 plus 1? Negative 5. So this is our answer. Alright? That's our answer. We'll go to B. Okay, so that's how we are supposed to answer this. Okay, so we want to find the inverse acting on x. So we are going to say here f of x is defined as it's y in short. So we say y is equal to 9 over 2x plus 1. You can say over 1, and so for x. We make x the subject. So you have y, when you cross multiply, open bracket 2x plus 1, 1 by 9, give 9. Alright? This by that, y by 2x, we have got 2xy plus y. The answer is 9. Alright, but here we are interested in x. So we have 2xy is equal to 9 minus y. Alright? So we divide by 2y and 2y. Alright? So that the 2y and 2y will cancel. We have got x is equal to 9 minus y divided by 2y. So now from here when there is x, we just put this expression for the inverse. So we say the inverse acting on x is equal to 9 minus, because there is x here, I put x divided by 2x, and this is your answer. Alright, so that's where we end for this presentation. So you can see that these things are not very complicated, they are very easy. We are doing ECZ, the Caribbean, school examination, certificates. This is your stuff. You can look at what we're presenting. Please don't forget to subscribe and share with your friends. Thanks so much.